Hi everyone, thank you very much for joining me. I'm going to go through a lab exercise where we're going to configure Etherchannels. So the main objective of this lab is to configure Etherchannel between these two switches here. So I've got switch 1 and switch 2, and they're both linked together using fast Ethernet 013 and fast Ethernet 014. So we're going to bundle these together into a port channel. I'm going to make a port channel 1. So for those of you not aware, Etherchannel is a method of allowing you to bundle multiple links into a single logical link. So you can bundle up to 8 fast Ethernet or gigabit Ethernet links, and to the end switches. By creating this port channel, it looks as though it's a single link. One of the main advantages is when it comes to spanning tree. If you do have multiple links for resiliency, then if that was just configured, if these fast Ethernet 13 and 14 were configured as separate links, i.e. just trunk links, then the spanning tree instance would do its calculations, and one of those links will be forwarding, but the other one will be blocking, because it's trying to avoid loops within the network. So spanning tree instance automatically blocks one of those links. But by configuring Etherchannel, you end up with a single interface, a single port channel, with the two links bundled into that port channel, and the spanning tree instance treats that as a single link. And therefore, if one of those links was to go down, then it wouldn't make any difference to the port channel, and it wouldn't make any difference to the spanning tree because it would still be forwarding. Another great advantage is that you can utilize both of those links. So you can send data through both of those links, and you can do load balancing on the port channel as well. So you can do source destination MAC address load balancing, or source destination IP, or a combination of source destination MAC and IP. So it's very useful in that sense that you're able to utilize both of those links and still have your resiliency just in case something goes wrong. If one of those links goes down, your port channel still stays up and everything carries on working like normal. Okay, so in terms of configuration, there's two different types of Etherchannels. So you've got the manual configuration, where you just turn the Etherchannel on. So there's no protocols or anything to be run. You just go in there into the interface and just turn Etherchannel on. That's fine, and the other alternative is to use the automatic configuration. In the automatic configuration, you have two options. You've got PAGP and LACP. Now, the main differences are that PAGP is a Cisco proprietary protocol, whereas LACP is an IEEE protocol. So if you have two Cisco switches, then it's fine. You can use PAGP, no problems. But if you have a Cisco and another manufacturer, for example, HP or a Juniper or a Nortel, Avaya, you have to use the LACP protocol. So that's the main difference. Now, in the PAGP protocol, there's two different options available. So the first one is the desirable, so you can have PAGP mode in desirable, and this places the interface into like a negotiating state, where the interface starts negotiations with the other end of the switch, the other device, and it sends PAGP packets to negotiate its parameters. So as long as the other end is desirable or auto, then it's able to negotiate its state. So that's the second option, is just auto. Important thing here is that if it's auto, then it'll never negotiate into a trunk. So you have to be very careful, and I've got a table further down which explains the different options. The second option here is the LACP. So again, LACP, you can have either active or passive. And the active is similar to the PAGP desirable, where it places the interface into a negotiating state, and it starts sending LACP packets to the other end to negotiate its parameters. In the passive state, it's basically sitting there waiting for the other side to activate the conversation. So it's not going to try and make any kind of LACP bundle link or anything, or Etherchannel. it waits for the other side to activate. But as long as the other side activates, then it will go into a negotiating state. Otherwise, it will just sit there and wait. So if you look at the different states and the switches, so here are the different states, and the first one is the on mode, which I explained. So if you've got an on mode, it doesn't use any protocol at all, and it forms the ether channel or the trunk, whatever you want to call it. If you got an on and auto, then again no protocol, but it'll never form a trunk. If you got on or desirable, it'll never form a trunk, because these two are basically PAG-P protocols. So if you've got one end set to on and you're trying to use PAG-P at the other end, it'll never try and form a trunk. Again, if you got on or passive and active, it will never make a trunk or an ether channel. The main reason for that is because this is the LACP protocol and it's not compatible with the on mode. So if you got one end on, you have to have the other end on as well. So the other options obviously are the PAG-P. So if you got one end set to desirable, the other end set to desirable, then it uses the PAG-P protocol, and yes, it will form an ether channel. If you got a desirable and auto, again it will use the PAG-P protocol, and an ether channel or a trunk will be formed. If you got both ends set to auto, then neither of the ends will send any negotiation packets, and therefore there won't be any protocol and there won't be any ether channel formed. So it's a very important table to remember this. Likewise on the LACP mode as well, very similar to the PAG-P. If you've got active, LACP will be formed and it will form an LACP ether channel. Active-passive, again, it will use an LACP protocol, and yes, you will have an ether channel or a trunk formed. If both ends are passive, then nothing will happen. You got no negotiation packets and no ether channel or trunk will be formed. Okay, so moving on to our lab. So I've got my switches already set up, and I've got a couple of routers ready to go as well to do our testing. So we'll configure the fast Ethernet 13 and 14, and we'll create the channel group 1 on both switches. And I've already pre-configured the routers, and they're assigned to VLAN 100. So VLAN 100 is allowed to go across this port channel. So once the port channel is up, we should be able to ping from one end to the other. Okay. Right, so I shall bring up my lab here. So I've got that's my router. Okay, let's just minimize that slightly. Okay, so got my lab set up already. So here we go. If we go on to switch 1, just do a quick check. Show run interface fast Ethernet 0/13 and 14. Okay, so there's no config on there at the moment. So we're going to conf t interface range fast Ethernet 0/13-14. Enter that. Okay, and the command to put that into a group or channel group is channel group 1 mode, and these are the different options that I was talking about. So you've got the on mode, which turns the ether channel on, or you've got active and passive, which is for LACP, or auto and desirable, which is for PAG-P. So we're just going to do the on mode. So quickly put that on. As you can see, it's created a port channel for you automatically. So that's the logical interface that we're talking about. Okay, and then if we go into the port channel, so interface PO1, you can see that's come up already. We change the, put the trunking configuration there, switch port mode dynamic, and we'll just go for desirable. So that's the automated version of creating the trunk. You could fix it and say switch port mode trunk, but we'll just go with the dynamic desirable. Okay, so that's switch 1 configured. Just have a very quick look at the config. Interface fast Ethernet 0/13. Yep, that's fine. And then 14, that's fine also. And then show run interface PO1, and that's fine also. So let's move on to switch 2. Show run interface fast Ethernet 0/13. No config on there. 14, and okay, so we'll just do the same commands. interface fast Ethernet 0/13. Okay, let's just do the range command. -14, and then it's channel group 1 mode, and again we're doing the on mode, so put it on, and it's create the port channel. You could actually create the port channel before you configure that. It's not a problem, you can do it either way. You can create it beforehand or afterwards. Okay, and then go to interface port channel 1, and then switch port mode dynamic desirable. Okay, right, so if we just come out of that, do a show Etherchannel Summary, and yep, so that looks like it's formed. So if you can see that protocol, it's got no protocol on there, but the fact that you've got fast Ethernet 13 and 14 with a P in there, so the P actually stands for the bundled port channel, so it looks like it's bundled with the remote side. Okay, do a show interfaces trunk, and you can see that the trunk has been created, so we've left that in desirable mode, and the encapsulation is ISL. So because this is 3560, it supports ISL and .1Q. Some of the new modern ones do not support ISL, in which case it will just use a .1Q trunk. But all the VLANs are allowed. You just show interface port channel 1 switch port, and you can see that switch port is enabled, administrative mode is dynamic desirable, and the operational mode is now trunk. So it's formed the trunk between the other end. Okay, so it's a really good command to use, and the operational trunk encapsulation is ISL. So just do a quick check on the other end as well. So switch 1, show interfaces trunk. Yeah, and you can see that the trunk has been formed. It's desirable, and it's an ISL trunk, and it's trunking at the moment, and all the VLANs are allowed to go across. If you just do a show Etherchannel Summary, and again you can see that both of those ports are in the Etherchannel group 1, and it's set to P, which means that the P means it's bundled and the port channel is ready to go. So I've got VLAN 100 configured already previously, so if we just do a show spanning tree VLAN 100, and you can see that the fast Ethernet 01 is already forwarding, so that's where my router 1 is connected, and the port channel is also forwarding as well. So just have a quick look on switch 2 as well, show spanning tree VLAN 100. Yep, and you can see that that's where my router 2 is connected, and my port channel is up and running. Okay, so if I bring up a second terminal here, where I've got my router, and there you can see I've got a ping going already, and that's working perfectly. So if you just go to router 1, do a ping to the 10.1.1.2. Yep, and that's pinging as well. So if we set off a nice long ping on here, and then we'll bring down one of those interfaces and see what happens. So if we just do a ping 10.1.1.1, 2, and then repeat that as many times as we can, let that kick off. That's going off. So if we just shut down, so I'm on switch 2, so I'll shut down one of the interfaces. Okay, we shut that down, and we shouldn't see anything happen. So these pings are carrying on, no problems. You can see that the interface has gone down. If you do a show Etherchannel Summary, you can see that fast Ethernet 13 is down at the moment, D showing down, but the 14 is still up and running, no problems. And if you do show Etherchannel, show spanning tree VLAN 100, and again you can see that the port channel is still forwarding. So by shutting down fast Ethernet 13 has had no problems at all. The port channel's carried on going. So if we just shut down the other interface as well, so now everything should stop working. So just do a quick shutdown, bang, and it stopped working. So if you do a show Etherchannel Summary again, and both the links are down, and so no packets are forwarding. Show spanning tree VLAN 100. So the port channel has now disappeared off the spanning tree because both the interfaces are down. So let's bring them back up, and that should all spring back into life. We'll bring one of these up first. Okay, let's just do that. Show tree VLAN 100. And you see the port channel is already in. Show Etherchannel Summary. And that trunk is already, the port bundling has already come into effect. And as soon as the spanning tree comes back, so it's learning, still learning, so it takes around 30 seconds or so. Learning. As soon as that goes into the forwarding state, the ping will return back to normal. Still learning. Yeah, there we go. It's forwarding and the pings have started. Brilliant. Okay. Thank you very much for listening to me. Hope you found that useful, and see you on the next video. Thanks again.